Hi Internet, this is PWD Synapse with a new video on 3D printing and 3D modeling. Today's focus is on Blender, a 3D open source software we can use to create our own models. The video will show you how to configure and set up Blender properly to create your own models for 3D printing. We will have a look at the topics like how to set the scene setup, the measurement settings. We'll have a look into the object settings. We'll have a look on some of the add-ons that could simplify the overall process. So if you're interested, just follow me, have a look into the video. For those out there that do not know Blender, I will give a short introduction, where to download it and what you can do with Blender. Blender is an open source software. It's provided by the Blender Foundation. The Blender Foundation is a non-profit organization. They published Blender under a GPL license. Blender can be used free for any purpose, including commercially or for education. Blender supports the content production pipeline. This includes support for modeling, rigging, animation, simulation, rendering, compositing and motion tracking. Even video editing and game creation is supported by Blender. So Blender has a huge functionality. We will only use a small amount of its functionality for 3D modeling. Blender can be downloaded from the Blender website, following the instructions on the Blender download section. To get into the download section, just follow the link on the Blender website. Here you see there are different versions of Blender available for Windows, macOS, Linux and other versions. I'm using the 64-bit Windows default link to download Blender. After downloading and installing Blender, we can start to configure Blender. Get rid of the splash screen by clicking on it and we're ready to go. Now we can start and configure Blender. We want to create 3D models that we can later use for 3D printing. Currently Blender using Blender units as a measurement unit. To make the measurement units visible, we just activate the Properties panel to see the dimensions of an object. We can activate the Dimensions panel by using the menu item and using Properties, or pushing the N key to deactivate and activate the Properties panel. Currently, you see no measurement unit. This means it is the default unit, it's the Blender unit. A Blender unit is 1 meter. This means this square here in the background of the display is 1 meter by 1 meter. This is much too large for our design requirements. So I want to change this to a smaller size. I'm using the metric measurement system. To change to the metric measurement system and to use a smaller unit, I have to go into the scene setting. The scene settings is the third tab on the right panel. In the unit section, I can switch the measurement units. Selecting millimeters will now activate millimeters as the measurement unit in Blender. You can see that the display of the Properties panel has now changed and millimeters are listed here. Changing the size of an object, for example by using Scale, I can use the S key to change the scale, pushing S key, drag with the mouse, and you see the dimensions are changing in millimeters. Unfortunately, the display grid in the background does not change. So we have to change this in the display settings. In the Properties panel there is a section for the display. Go to the display section in the Properties panel and change the scale according to the unit scale in your measurement unit setting. So here is 1.001, and also here we insert 0.001. Now the display grid is also 1 millimeter. It is also possible to use Blender units during the whole modeling process. Instead of scaling my current 3D view and using the appropriate measurement units, I can use Blender units for modeling. But then I have to scale the output during the export to the STL format. I will show that later on. We can adjust the size of the grid floor to meet the dimensions of your 3D printer's print bed. For this we have to go to the Properties panel, go to the Display section and the grid floor settings. In my case, the Anycubic printer has a print bed of 210 mm by 210 mm. I'm setting this to 210 lines. Now we can clean up the 3D scene. Make sure you're in the object mode. Activate the default cube with the right mouse button click and push the X key to delete it. The light is not of use, and also the camera is not of use for our use case. Therefore we hide them in the 3D scene. Just activate the lamp object with the right mouse button click and go to the outliner panel and hide the lamp, and also select the camera and hide the camera. Get a better impression how your 3D object fits into your 3D printer's print volume, you can easily show your 3D printer's print volume by adding a cube into the 3D scene with the dimensions of the print volume. Therefore, we position the 3D cursor into the center of the scene. By pushing the Shift S button, cursor to center, make sure you're in the object mode, add mesh cube. Now we change the dimensions of the cube to the dimensions of our 3D printer's print volume. In my case, of the Anycubic E3 Mega, this is 210 millimeters on the x-axis, 210 on the y-axis, and 205 on the z-axis. Because we want to have the bottom of the print volume cube aligned with the grid floor, we will change the origin of the print volume cube and leave the minus 10.5 centimeters on the z-axis. I just do a left click on one of the faces, and I see here in the outline panel the cube is selected. I'm in object mode, cube is selected, and I reset the origin of the object to the 3D cursor. Now the origin of the print volume cube is located at 0, 0, minus 10.5. If I select the print volume cube, I can just change the location here to 0 and see the floor of the print volume cube is aligned to the grid floor. If I select the cube, I can now change the z-axis to 0 and the bottom of the print volume cube is aligned to the grid floor. We can delete some of the faces of the print volume cube because we are more interested in the outlines. Therefore, we just go into the edit mode and delete those faces of the print volume cube that we do not want to have. I prefer to leave two faces, so the background and the top face, because then I can use them for lighting in Blender, and Yeah, the other faces can be deleted. Using the mouse wheel, I go out of the 3D print volume cube and make sure that I've activated faces. I'm in edit mode. I'm selecting the faces and pushing the X key, and I will only delete the faces, not the edges, not the vertices, just the faces. So I do this for the front and the side. Only the faces, and for the floor face. So I still see my 3D printer's print volume here. What I can do now is I'm changing the normals, because currently they directing outside and I want the normals to directing inside for light reflection and light emission. The faces, and change the normals using the mesh menu item, normals, flip normals. So this is our 3D printer's volume, and this gives us a good impression how our 3D model fits into our printer's volume. Depending on your slicer software, you have to align the direction of the X, Y and Z axis to the direction used in your slicer software. In my case, I will use Cura as the slicer software, and this means the Y-axis needs to direct away from me if I stand in front of the printer. To achieve this, I just rotate the print volume cube by -90 degrees. Therefore, I go into the object mode, selecting my print volume cube, push the R key for rotation, the Z key to select the axis we want to rotate around, and -90. So now the Y-axis directs to the background, away from me if I stand in front of the printer. Now we can add an object to our 3D scene. This object we want to print on our 3D printer later on. The first thing we do is we're positioning the 3D cursor in the center of the grid floor. The 3D cursor is here. Push Shift S and set the cursor to center. Now add a new object. We want to add a cube. Therefore, go into the Add menu, make sure you're in object mode, go to Add, Mesh, Cube. The cube is currently very small. It's only 2 mm by 2 mm by 2 mm. We change this to 20 mm. To move our view position directly in front of the cube, we just pushing the period key. You can use the mouse wheel to zoom in and out. Pushing the mouse wheel and hold it down while moving the mouse will rotate the 3D view. What we see is that by default the origin of a new object is the mass center of the object. This is the default setting. For exact positioning of the object in a 3D scene for later printing, it might be useful to set the origin of the object to one of the corners of the cube, so your measurement will start from there. Therefore, just go into the edit mode, make sure the vertex select is activated, select one of the corners with the right mouse button click, move back to object mode, go to the object menu, transform, origin to 3D cursor. Now the origin of the object is in the lower left corner, as you can see. If we want to positioning the object in the center of the 3D view, we just can now insert the center location into the properties panel. Now the object is exact positioned in the center of the 3D view. To give the cube a little bit more interest, I will modify the sides a little bit. So I'm currently in edit mode. I'm changed to the face selection mode and then going to the right side and selecting the faces to create an X letter and drag it a little bit to the outside, something like that. Then I go to the back side and select the faces to show a Y letter. So I will not drag it too much because I don't want to deal with support structures. So this is a topic for a later video and we will mention it later. On the top side I mark the Z axis direction, something like that. Use the select tool, push the B key and use the select tool to select some of the faces. Same on the front side, B, and again here. So now we have a nice little object and we can continue to prepare this object for printing. Therefore we have to convert it to the STL file format. To export the file to the STL file format, we have to activate the STL export plugin. You'll find this under File, User Preferences, Add-ons. If you insert STL in the search dialog, you should see the Import-Export STL Format add-on. Just activate the add-on and save the user settings. Now it's time to export the object. Make sure you are in object mode, select the object and go to the File menu, menu item Export, submenu STL. STL is only visible if you have activated the STL export add-on. The Export STL panel has several options. It gives you the ability to change the direction of the coordinate system you used in your 3D scene during the export. You can change the forward direction and you can change the up direction. This setting will affect all objects in your export. If you select selection only the selected objects of your 3D scene will be exported. The scale parameter can be used to scale all objects during the export. If you check the scene unit, the measurement unit settings of the scene will be used. If you check the ASCII option, the file will be saved in ASCII format. The Apply Modifiers checkbox gives you the ability to apply modifiers. The modifiers will be applied to the related objects. If you have multiple independent objects in your export, you can decide if you want to have them in one file or multiple files. If you select Object, then there will be an individual file for each object. We will use the Y forward direction as the forward direction for the export, the Z up direction as the up direction for the export. We will export only the selected object. We leave the scale as it is. We use the scene measurement units we set. We don't want to have ASCII file format, and we want to apply modifiers. Currently we do not have any modifiers, but it makes no difference. We can leave it checked. And we want to have one file for all our objects. Now I can export the STL file. Now we have exported the object to the STL file format on the file system. We can now use a slicer software to open the STL file. In my case, this is Cura 3.04. In Cura I can open the file, select the file from the file system and open it. This is our object in the slicer software. We see that the X direction, the Y direction and the Z direction are set up correctly. In the following videos of this tutorial, we will have a deeper look into the design process of 3D objects for 3D printing in Blender. We will have a look on some of the add-ons that support us during this design process, like the Measure It add-on, and more important, the 3D Print Toolbox add-on, which we can use to check and test our 3D objects after the design process to validate that the objects are ready for 3D printing. More on that in the next video. If you have questions or comments, please leave them in the comment section. If you found this video helpful, give me a thumbs up. See you in the next video.